Hello, welcome to the review of the answer key for the practice problems. First, just in case anyone doesn't have the worksheet, here are the problems that are on the worksheet 1 through 4. You can pause the video if you need to see those longer to copy them down. And here's 5 through 6. Next, we show the answer key for anyone who just wants to check on their own. And if there's any problem that you had trouble with or want to review extra, you can stay tuned and I'll go over the problems a little more in depth in the walkthrough of the answer key. If you need to see these longer, just pause the video. And here are the answers for 5 and 6. Okay, so taking a look for number 1, the format of this, the structure is the ax squared plus bx plus c kind. And since we have 3d squared to start, we're going to start with 3d and 1d. And then to multiply to 5, the only options are 5 and 1. Now we want to multiply to negative 5, so we're either going to be using minus 5 and 1 or plus 5 and negative 1. So we have to try different combinations of these numbers here, because it could be minus 5 and 1, or it could be 1 and minus 5. Those are different. Or it could be positive 5 and negative 1, or negative 1 and positive 5. So even though there's only 2 breakdowns here, because they can go in these 2 positions, there's actually 4 possibilities right now for our factorization. So keeping in mind that we want to get a 2d from the outers and inners, if we try a 5 here and a 1 here, I'm going to ignore the signs for a minute. That gives me 5 and 3. Well, those add to 8, but the difference is 2, so this might be a possibility. If I try a minus here and a plus here, that's going to be negative 5d and plus 3d. That does not work because that gives me a negative 2. So what I need instead is a plus here and a minus here. So this doesn't necessarily have to be instant that you are able to factor this when there's a coefficient other than 1 in front of the x squared. But using some guess and check, you should pretty quickly be able to check those outers and inners to find a correct factorization for that problem. For number 2, I threw in a GCF. These 2 terms have a GCF of 2. So if we factor a 2 out of here, we're left with 25. Factor a 2 out of here, we're left with minus x squared. And then this is a difference of 2 squares. There's no need to rearrange the terms. You can just take the square root of 25 to start both, take the square root of x to end both, make one a plus, make one a minus. Make sure your GCF is in your final answer. If you're missing 2, your factorization is incorrect. Because if you're missing the 2, you would only get 25 minus x squared when you multiply that out. But what you want is you want 50 minus 2x squared. So you need the GCF in your factorization. Now, for anyone who likes to factor the 25 minus x squared, this is preferred, what I just showed you. But sometimes students like to rearrange the terms. So that the x is first and the number is second. So you technically can do this. So if you rearrange the 2 terms, you actually could factor out a negative 2 instead of a positive 2, and that will change this to a minus 25, and you'll have x plus 5, x minus 5. So this is also correct. There's nothing wrong with it, but this would be a little more expected in pre-calc. Number 3 should have been pretty quick for you. Number 4 does not factor. I mentioned I'd throw one in that didn't factor. No matter what you do, you're not going to find 2 numbers that multiply to negative 8 and add to 5. For number 5, I do not like when my leading coefficient is negative, so I factored out a negative. If you prefer that that be a negative 1, you can factor out a negative 1. When you factor out a negative or a negative 1, you are changing all the signs. Because when you divide this by negative 1 or factor out a negative 1, it becomes positive y to the 4th. When you divide this by negative 1, you get positive 3y squared, and this becomes minus 4. So now you want to factor this expression that's inside. Since it's y to the 4th and a y squared and a constant, this has the same structure as a 1x squared plus bx plus c type of factoring. So we're going to keep the negative out front, and then we're going to put a y squared to start both. That way, when we multiply, we're going to get y to the 4th. And when we add inners and outers, we're going to get a y squared term. So what multiplies to negative 4 and adds to 3? That's going to be 4 and 1, where the 4 is positive and the 1 is negative. So that's how I got this expression here. I wrote the two factors in the other order, but we know that that's equivalent. And then finally, this is a difference of two squares again. One is a perfect square, so we end up with y plus 1, y minus 1 for our final answer. Now I gave some variations here because if you don't mind factoring when there's a negative out front, you can actually factor this straight away. What would happen is if you were to factor negative y to the fourth minus 3y squared plus 4 with that negative, you would have a negative y squared and a positive y squared. And then you're still going to use 4 and 1 here, but you have to figure out which way it goes because you have to check your signs. So that's why I don't like doing this. My personal preference is to factor out that negative so I have a positive 1y squared to start. Much prefer that. It's much easier for me. So if we were to put a plus here and a minus here, we'd have to check all the signs to see if that works. That'll give us the y squared, and you even have to check first and last, not just outers and inners. This will give you negative y squared. This will give you a minus 4, and you want a plus 4. So that's not going to work. So you can try both plus. Okay, that'll give you negative y squared for first times first. Last times last will give you 4. And your outers and inners, okay, that will work for your factorization. So if you have this, you can then have to recognize that this is a difference of two squares. I think I've probably convinced you this is not what you want to do. I think it's much easier to factor out that negative to start. So if you swap the order of those terms, you'll see that you have a difference of two squares, but you'd have to recognize that. So I think this is much tougher. Another way to do this, if you go to factor straight away with the negative out front, this will also work because so instead of having negative y squared plus 1 and y squared plus 4, you could instead have negative y squared minus 4 and positive y squared positive 1. And that works because if you multiply first times first, you do get negative y to the fourth. And if you multiply the outers and inners, you're going to get minus 3y squared, minus 4y squared. Oh, I have that incorrect. I really don't like this method for myself. I'm sorry, you'd have to have a minus 1 there. Sorry about that. So this will give you, first times first will give you negative y to the fourth. The outers will give you plus y squared. The inners will give you minus 4y squared, which gives you the minus 3y squared. And last times last gives you 1. So then you can factor this difference of two squares and get this answer. So there really are a lot of answers you could have here, but I think you're probably convinced this is the way to do it. If you have a negative leading term, factor out that negative 1. Your life will be so much easier. And you can totally have that negative 1 in the answer, by the way. All right, and the last one is 4 terms. So even though it's multivariable, we're going to try factoring by grouping. The GCF of these two terms is x squared. And when you divide that out of this term, you're left with y squared. When you divide that out of this term, you're left with 5. I brought down the minus. The GCF of these two terms is just the 8. When I divide this by negative 8, I get positive y squared. When I divide this by negative 8, I get positive 5. I have that perfect match. So my mini GCFs make one factor, and my matching expression makes a second factor. If you check this by foiling it, you do get this expression up here. So it's a correct factorization. And you can't factor this one any further. If you think this might be a difference of two squares, it's not, because 8's not a perfect square. I don't know the square root of 8. It's some crazy decimal. All right. Thanks for watching.